I would like to demonstrate a network that we have here that is composed of both a set of sensors generating events, a database here in the middle that can fail, and if the database fails, the events will not be saved to disk, and instead a contingency plan will be activated. The contingency plan is down below over here, with a number of checks that can be made and a number of repairs that can be done in order to get the database back online. Let's run a demo here and watch how this works. You can see these tokens coming through, generated by any one of the three sensors that are running. Let me pause that and show you how the sensors generate. If we look at one of these sensors up here, these red transitions are actually components. I'm going to zoom in on one of those. The generator generates events containing a simple ID, a counter, and that is sent out into the sensor. So if we look out here, you see all three of them are being generated. What we do with the upload transitions is we put these events into an array containing a number which tells you which of the three sensors the data came from. So when we look right down at the database, we'll see each token that is saved contains both the index counter as well as the sensor ID. So we can see that we have 4 events that have been saved coming from sensor 3113, and there are events 0, 1, 2, 3. And you'll see that not a single one has come from sensor 2, and this is purely a random selection up here. But we can see already coming out of sensor 2 is one event. Event number 4 will come down and have sensor 2 on it. So let's fire a single transition. Bang! It appears down here. You can see that it has the event ID as well as the sensor ID. Let's fire another one. Bang, and it goes into the database. Next thing to look at is the database. Let's look inside that persist object. That's a bit more complicated. At the top here, we have the input and output flowing through a flow transition. So basically, this flow transition is the save action. This database can save things if there is a token here in the middle in the enabled state. And you can see there is. So at the moment, data flows. Let's run it for a few seconds, and you should see things appearing in the input and moving to the output, appearing in the input and moving to the output. Let's stop it again, and I will explain a little bit more. How will this database save action stop working? If the token in the enabled state is moved down to the disabled state, and that means there's no token in the state up here, the flow transition, which is the save action, cannot happen. How do you get the token in the enabled state to move to the disabled state? Quite easy. Put a token in the off switch position over here on the right. And you can see we've already modeled a few failures. We have a network turned off, a server stopped, disk failure. Any one of these failures will trigger the movement of this token from enabled to disabled. And the token in one of these failure tokens that causes that will be moved into the alert state so that we can take further action. Let's run this until we see that database turn off. Alright, it should occur very soon. There we go, I've stopped it. What we saw happen there was the first of the failure tokens, the network off failure, was ready. And the reason it took a while to fire was simply this time setting on it. It was not available until time unit 10, which has now occurred. So it moved from the off to the alert state, and that also triggered the movement of the token from enabled to disabled. So now information will stop flowing from input to output. And if I continue to run this, you'll see that happen. I'm going to come back and show you that, but I want to show you something else more important now, and that is what happens to the alert. This network off is going to be processed by the contingency plan. So let's go back to the main network, and you'll see here it is. There is the token sitting here at the bottom of the screen, the network off token. It used to be up here where we've put in our modeled failures, and it got moved down to here, blocking this persist transition so that this no longer works. So let's look down. I'm going to move the whole screen up. Look at the contingency plan we see here. This is also composed of Petri nets. However, we've simplified the view slightly. All of the transitions inside the contingency plan are made very small because they are of only 3 types. Next transitions are the blue ones, and these simply mean a token can move from one transition through the next state to another transition. The red and green states are all pass-fail states for these red transitions here, which are components that perform a certain check. So in this contingency plan you can see 6 of these red transitions, 6 components that check a pass-fail condition. And we've named them in a descriptive way. So the first one checks if we can access the database. Is the database working? So of course the first time this is checked it should return failure, because we are modeling database failures, and a database failure has occurred. So it will model a failure. It will come down here. We can check, is the server that the database is running on, is that working? Is that accessible, I mean? If it's accessible, we check the network. If the network is if the server is not accessible, we check the network. If the network is not accessible, we repair it. Move the token back up here and check from the beginning again. Let's run this first one, the network off, because that will follow the path I've just described. Alright. It went through that exact path that I described, and you can see it's moved up here to the database broken state, but it's changed. It now says fixed network off. So what happened was the token moved down here, it failed the test, moved down here, failed the test, moved down here, failed the test, went into the repair network. The arc coming out of repair network, you can see it quite clearly if I move it up here. What that arc does is it says append or prefix the token with the word fixed and put a time offset on it of 5 time units. What this means is the token will be modified to now say that we have fixed the problem, but we also model that that fix took 5 units, so this token will not be available to fire again until 5 time units later. So if we look at our database, there is a bit of backlog occurring here. That is because it's taking time to repair the network. So the original 10 tokens that made it to the database are still there, but new tokens are coming in. New sensor events are coming in, and they're not being saved. So let's run this for a bit longer, and after 5 time units you'll see the fixed network token will be rechecked, and this time it will pass the access check, move into the repair state, and the repair state will fire the internal switch inside the database persist, and the database will be enabled again.